Let's try to solve this question here. You have a bird stands on a high voltage transmission wire with its feet 4 cm apart. The wire is made of aluminium with diameter of 2 cm and carries a current of 100 ampere. Okay, so let's try to sketch a situation first. Okay, they also say the resistivity of aluminium is 2.65 times 10 to the power negative 8 ohm meter. Okay, so maybe we sketch the transmission wire first. Okay, so this is our transmission wire. What do we know about the wire? The wire has a diameter of 2.00 cm. So the diameter is equals to 2.00 cm, and it carries a current of 100 ampere. So it carries a current of 100 ampere. Let's draw maybe a current flowing through this wire, and it has a value of 100 ampere. Okay, so a bird stands on this transmission wire. So let's draw a bird standing on it. Okay, this is the challenging part. Okay, so forgive me if I'm not drawing it very well. So a bird, something like this. Okay, beak, the wings. Not very good at it, but I think you roughly get the idea of it. Okay, so haha. So this is the leg of the bird, slightly white just for illustration. Okay, so they say that the bird, its feet is 4 cm apart, so the distance between these two legs here is 4 cm apart. Okay, so that means by the section of the wire that the two ends of the wire that the bird is holding on to will be 4 cm. That's why we can label this to be our length of our wire. The length of wire that we are talking about, it's 4 cm over here. Okay, the leg here is just to illustrate the situation here. Okay, just tell you which section are we interested in actually. Okay, because the question says the resistance of the wire between the bird's feet. So they're not interested with the whole transmission wire over here. They're only interested with the part in between the bird's feet. Okay, one thing that we still haven't add on to our diagram here is the resistivity of the wire. And since this wire is made of aluminium, so the resistivity of aluminium is relevant here. It will be 2.65 times 10 to the power of negative 8 ohm meter. Okay, so this is what we know about the situation. Let's start and solve the question right now. So we asked for the resistance, they asked for the resistance, and we know that resistance depends on 4 factors, which are the length, the cross-sectional area, the type of material, and also temperature. We can see very clearly that temperature is not involved here. So there's only 3 factors: the type of material or the resistivity of the material, the length, and also the cross-sectional area of the wire. So these three factors here will combine into one situation to see how they affect the resistance, and the equation will be R is equals to rho L over A. Okay, so to use this equation, one thing you have to be aware of is you have to change this length to be meter and have to change this diameter here to be area, because here this is cross-sectional area, and cross-sectional area here can be obtained using this diameter over here. Okay, so let's change a bit the equation to express it in terms of diameter. We know that this is a circular area, so it's pi r squared, but the radius here can be obtained by halving the diameter. So this pi r squared is changed to become pi bracket d over 2 squared. Okay, so once you've converted it this way, you can substitute in the value. Your rho is 2.65 times 10 to the power negative 8. The length of the wire that you're interested with is the section in between the bird's leg. So this will be 4 cm or 0.0400. Okay, continue. You need to put in your pi. Then your diameter here is 2 cm, but you change it to be in meter, so this will be 0.0200. Diameter divided by 2, this will be radius square. Okay, so everything is here. What you need to do is just calculate it, and I believe through your calculation you get that the resistance is equals to 3.37 times 10 to the power of -6 ohm. Okay, so that's resistance. Next, the question asks for the potential difference between the bird's feet. So in between the bird's feet, you know that there's a current of 100 ampere flowing through it. Okay, the current along the whole transmission wire will be constant. It will be constant at 100 ampere, because if there's 100 of coulomb of charge flowing through the early section of the wire per second, then at the middle section it will still also be the same 100 coulomb of charge flowing through the wire every second as well, and that applies to the late section of the wire as well, because you can think of it like a water current. If there's that much water flowing at the upstream, okay, if there's that much water flowing through the upstream, that same amount of water will flow through the middle stream, will flow through the downstream as well. So the current should be constant along the length of the wire if there is no junction. Okay, if there's no junction, then there's no other path for the water to flow. So if all the water will have to follow through the same path, then you should expect that all sections of the wire will have the same current. Okay, because the water cannot escape to other path anymore. Okay, next, the potential difference between the bird's wire, you have the current flowing through this section, and you know the resistance of this section. So this is basically just a simple relationship between V and I, where you can get it from the definition of resistance itself, or you can think about it as Ohm's law. Okay, so Ohm's law says that V is equal to IR, where R is constant. Okay, so R is definitely constant for this case. We have the value, so we just do our substitution. So the current is 100 ampere. The resistance is 3.37 times 10 to the power of -6. So if you do your calculation, I believe you get the voltage or the potential difference to be equal to 3.37 times 10 to the power of -4. Okay, so this will be the voltage of the section of wire in between the bird's feet. Okay, or you can call it as the potential difference between the bird's feet. So this is a simple example of how we apply the three factors that affects the resistance to calculate the resistance, and we use the resistance and apply it in and use the definition of resistance to determine the potential difference by knowing that resistance is actually the ratio of potential difference to current. That's it for this question. Thank you very much.